Hello everyone, in this session we will discuss orchestration. So why do we need orchestration? So we have moved into large data centers. So we have created a lot of containers and from virtual machines we moved on to containers. And the advantage of containers is because of rapid creation, short lifetime and replication. And when there are large of containers, so when an application contains large number of containers, it becomes difficult for managing those containers. So we need to have three managements. One is dynamic scaling of services, then coordinating across multiple servers. Then in case of there is a problem, you have to have an automatic recovery. So all this should be managed automatically because the number of containers has increased and we cannot handle it manually. So we have a technology called Kubernetes, which is an example container orchestration system. And there are key features which service naming and discovery, load balancing, storage orchestration, optimized container placement, automated recovery, management of configurations and secrets, automated rollouts, and rollbacks. So in service naming and discovery, the Kubernetes automatically provides a DNS name, IP, address, and enables for uh, automatic discovery of services. And load will also be balanced according to the request. So in case a number of requests for a container increases, a new container instance will be created and requests will be forwarded. Similarly, storage orchestration, then container optimized container placement. So if a number of requests for a container is reduced, then other remaining requests will be forwarded to the running containers and the unused containers will be terminated. So we have a lot of applications. There are few limitations on Kubernetes, and one is because of they do not specify a particular application, they do not manage source code or build containers, and they do not supply event passing middleware, and they do not handle or monitor events. So Kubernetes provides container orchestration, which means it automates the deployment and operation of a set of more containers. Kubernetes uses the term cluster to describe the set of containers plus associated support software. So containers in the cluster, each container will be given to different users, and you have the Kubernetes software that um, manages the containers. And you can see in a cluster there will be number of nodes. A number of nodes together form a cluster, and each node will contain one or more pods, and each of these pods will have containers in it. And you can see you have the number of pods, and you have worker nodes and the other manager nodes. So control plane. So you have a number of pods, and one pod will act as a worker node, and the rest of the nodes will have the application running. And in each pod, you will have a number of applications and number of containers. And we need to allocate resources. To allocate resources, we have init containers which will allocate resources, and then followed by the application containers. So the control plane, there are few components. One is the API server, which provides an interface to the control plane. You have the scheduler, which chooses a node that will run a pod. You have the cluster state store that stores the state information of the cluster. You have the control manager that handles controllers that operate the cluster. And you also have a cloud control manager that handles cloud provider interactions. So all these are together found in the master mode. The others are worker mode where the exact application will get executed. And to manage this, you have the server proxy, which is run in the worker node. So in the worker node, you have the server proxy, which configures the network on the node. You have kubelet, which uses the container software to run and monitor pods. And you have the container runtime, which is the standard container software or the Docker engine. So these are the services that will be run in the worker node. Thank you.